Hello and welcome to another video. In this video we're going to be working on neighboring bitwise XOR. And in this one you have a zero index array derived with length n, and it's derived by computing the bitwise XOR of adjacent values in a binary array original of length n. Specifically for each index I in the range 0 to n minus 1, if I equals n minus 1, then derived I is original I XOR with original 0. Otherwise, it's just the original of that index and the index after. Given derived, your task is to determine whether exists a valid binary array original that could have formed derived. Return true if it does, and false if otherwise, and a binary array is an array containing zeros and ones. So in this first example, if derived is this, then basically one valid array is this, and that's because to get this value, it's these two values XOR'd, which would be 1. To get this value, it's these two values XOR'd, which would be 1. And then to get this value, it's these two values XOR'd, which would be 0. So this is valid. And in the second example, if it's 1, 1, the array would be 0, 1. And so this would also work because to get this value here, like if it's 1, 1 up here, to get this value, it's going to be these two XOR'd, and to get this value, it's going to be these two XOR'd as well. And in the last example, we can't get this because, so let's kind of walk through how we would do this and show why we can't get this. So if this is derived, and let's take a look at what original has to be. So if this value is a 1, in order to get a 1 in an XOR, it's either 0 or XOR 1 or 1 XOR 0. And we can basically just try this. So if this value is 1, it's going to be this number XOR this number. So it either has to be 0, 1 or 1, 0. Well, let's see what happens if we put in 0, 1. So we put in 0, 1. That's the whole original array. Now, this value is these values also XOR'd. So because this value is these two values XOR'd and this value is these two values XOR'd, they can't both be 1 and 0. So the other way would also fail if I do it, this way. But that's kind of like the way you could solve the probably most intuitive way you could solve this problem is if I have some derived array. Like, let's take a look. Let's say our derived array is like whatever 1 0 1 1 1 1 0 1 0 1 essentially. So this is our derived array, and we're trying to get the original. We can basically just say like, okay, well, there's only going to be at most 2 different things we have to try. So essentially what we can say is like, if this value is 1, this value is made from these two. In order to get this either has to be 1 0 0 1. So maybe we'll try 1 0 first. And if we try 1 0, then this value is these two. So to get 0 from 0 and what? That's going to be 0 as well. And then here is these two. So to get a 1, we need a 0 and what? A 1. Then this value is these two. So this has to be 0. Oops. Then to get this value, it's these two. So 0 and a 1. Then to get this value, it has to be these two. So this has to be 0. This value is these two. So this has to be 0. This value is these two, so it has to be this. This value has to be 1 and 1. And then we just check for the last thing, did we get what we wanted? So this XOR this has to be 1, and it's not. So that failed. So 1 0 failed. And now we can just try the other way, right? 1 0 failed, we can try 0 1. So let's make this again. Yeah. Okay. So now essentially we'll try 0 1, and if that doesn't work either, then we know we can't do anything. So 0 1. So to get this value, it has to be these two. So to get a 0 here, it'd have to be 1 and 1, or 1 XOR 1. This value is these two, so this has to be 0. This value is these two, so this has to be 1. Then this has to be 0. Then this has to be 1. Has to be 1. Has to be 0. And then has to be 0. And now we check again. Did this value work? So this value is both of these, and 0 is not 1. So there's no way of getting this array. And that's basically how you could do it, like a brute force. Basically, from the first number, if it's a 0, then you know your first two numbers have to be either 1 and 1 or 0 and 0, and we can just try both of those and then go from there and see if you get a result. And if the first number is a 1, then it either has to be 0, 1 or 1, 0, and try both of those and see if you get. So essentially you just make two different arrays, and yeah. Now there's like a math way to do it. It's a little bit tricky, and basically it relies on a bunch of like properties of XOR. So let's say we have this derived array. Let's just go with 3 numbers. So derived 0 is original 0 XORed original 1. Maybe let's use a different letter for original. Maybe let's call it like R or something. Okay. And then we have 2 more of these. So derived 1, derived 2. So derived 1 is original 1, original 2. And derived 2 is original 2 and original 0. And from properties of XOR, if we actually XOR all of these, so if I XOR R0 and R1, and then I XOR that with the next thing, right? So that's this piece here, and then I XOR that with this as well. So XOR like this, and finally one more, this one. So what does this have to be? Well, XOR, if you XOR a number with itself, and the order doesn't matter, it's 0. So here we have 0 twice, we have 2 twice, and we have R1 once. And this will always happen, right? Every number will be used in a calculation twice. So this is 0. So XORing this whole thing is 0. And you can basically just use substitution. Like if X equals A XOR B, we can just substitute this with X. Right, so we can substitute this with D0, we can substitute this with D1, substitute this with D2. So basically, if you substitute here, you get D0 XOR D1 XOR D2 is 0. So essentially, in order for this to be the case, the derived array, the XOR of all the numbers in the derived array has to be 0. So we can just take every number in the derived array and XOR it with each other. And what does it mean also when you have, if all your numbers are 0 and 1, what does it mean if all your numbers XORed are 0? Well, XOR is just like, do I have an even number of ones or an odd? And if it's even, then your XOR will be 0, and if it's odd, it will be 1. So all we have to do is just we can either XOR everything, or we could just take the sum of our derived array and mod it by 2. Basically count how many ones we have. Either one works. Either XOR the whole array or take the sum and mod 2. And that'll give you your answer. And the derived array has to have an even number of ones. So this one does, so this works. This one does, this works, and this one doesn't. Yeah, so that's the solution we're gonna go with. Just basically go through XOR all the numbers. So pretty simple. Or you could do that simulation that I showed as well. I think that's more intuitive. This one's less intuitive. And either one's going to be linear runtime. This will just be over one space. So here, like I said, we can do an XOR or we can do a sum. Either one's fine. And then the result has to be 0. Or if you did a sum, the result had to be a mod. Okay. Let's see if we get any errors. Okay, there we go. So yeah, basically it for this one, just properties of XOR. Main properties you have to know of XOR is, like a lot of them are like addition. You can move numbers around, you could substitute. And there's also like an inverse property, which is like not in sum, which is like if A XOR B equals C, then C XOR B equals A, and so on. But honestly, like you can figure out a lot of these once you know how XOR works. Just try a bunch of numbers and figure it out. Like if once you realize like all XOR doing is just counting how many ones I have, then it makes a lot of sense why that's the case. Yeah, so it's going to be linear and constant. So yeah, hopefully this is helpful. If it was, please like the video and subscribe to the channel, and I'll see you in the next one. Thanks for watching.